Let's start by looking at the Grind 75 question list by starting with the first problem, TwoSum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So the first example they have is 2, 7, 11, and 15 with a target of 9. The answer should be 0 and 1, and these are indices, and these are not values, right? Because 0 and 1 represent the 2 and the 7, and those two numbers will add up to 9. And if we look at the next example, right, you can see that we have the 1 and the 2. The 2 plus the 4 will give us 6. And the last example of to make target 6 is we have two values of 3 and 3, and we're going to return indices 0 and 1, which will of course give us the 6. If we look at the constraints, we can see that we're guaranteed to have at least two numbers, so we don't have to guard against any of those kinds of corner cases as well. We should also note that the numbers, or the numbers that they're giving us as well as the target, are signed integers. There's guaranteed to be exactly one answer. Okay, so let's look at the TwoSum problem and think about how we can solve this in an efficient time complexity and space complexity. So the first thing that we should note is that we have numbers of 4, 5, and 6 in this example, and we have a target of 10. So what we really want to do here is think of a way to determine if, whenever we loop through our numbers, if we can determine, is this current number going to be able to add up to another number to make up our target of 10. Now in this example, you can see that the 4 and the 6 are going to add up to 10, obviously. So if we look at the actual formula, right, so it's going to be some addend plus some other addend is equal to 10. But we don't know what the other addend is, so what we're really going to look at is t, which is our target, minus whatever specific number we're looking at. I'm just going to put this as nums of I for now, and is that in our set? So we're going to say, is this in our map, or in Swift we would call it a dictionary. How's that going to work? So whenever we look at a set or a dictionary, whenever we're checking to see if an existing value is in there, that's going to be a runtime factor of 1, right? A constant runtime, which is why we're going to use the map. So we're going to make a map, and in our map we're going to have an integer, and this will represent the value from nums, right? So the 4, the 5, and the 6, for example, as well the key, or sorry, the value in the dictionary, not to confuse with this value. This is going to be the index of num, right? So this would be 0, 1, 2, for example, the actual index. So what we're going to do is look at an example, this specific example right here, and we're going to run through the algorithm. So we're going to start at the 4. And by default, our map is going to be empty, right? There's not going to be anything in it. So we're going to start at the 4, and we're going to ask ourselves, all right, so if the target of 10 minus the current number that we're looking at, 4, which is 6, of course, if this is in our map, then we can go ahead and return the solution. Of course, it's not, so what we're going to do instead is we're going to add it to the map. So when we look at the next number, 5, we're going to see that we have the number of 4 right here, and the actual indice is of course 0 because it's at the beginning, and that's going to be the state of our map currently. Now when we hit the 5, what we're going to do is the exact same thing. We're going to say if 10 minus 5 is in our map, and we can see there's only a 4 right now, so it's not in there, then we can return our solution. Of course it's not, so what we're going to do instead is update our map. So when we get to the 6, we're going to have the 4 again, and we're also going to have the 5. Now when we get to the 6, we're going to do the target, which is 10. We're going to say, is the target of 10 minus the current number, which is 6, is this in the map? Well, of course, this is 4, and we can see right here, ding, 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 we have it. So we're going to return the indices that will make up our solution. So if we look at the 4 here, the matching index is 0, right? So we're going to return a 0. And as we're iterating through, we're going to have access to the index. So this is going to be 0, 1, and of course 2, which solves the problem. And the time complexity is going to be a linear runtime, and that's because we actually have to loop through all the numbers. And the space complexity is also going to be O of n because we have to potentially, in the worst case scenario, store basically every number that we've got. Okay, so let's look at the code. So the first thing we're going to do is actually create a map, right? So we're going to create our map, and it's going to be equal, it's going to start off with an empty map, and it's going to be from integer to integer, and this is going to basically be number value to index as a reminder. And then we need to loop through our numbers. So we're going to say for I in 0 to nums, or 0 to nums.count, and this will also give us access to the index for all the numbers that we're looking at. So again, we're really just asking one question here. If our map contains the target minus the current number that we're looking at, so this is nums of I and not I, then do something. But we actually want to get the matching index. What we're going to do in this case is return the matching index and I. You could also return this as I and matching index, it really doesn't matter. Otherwise, what we're going to do is take our map and update the value and the key for this particular entry. So remember, it is going to be the number value to the index. So the number value is going to be nums of I, and we're going to set that equal to I. And this would normally solve the problem. It's just that the Swift compiler is not going to be too happy because it's going to say, you know, it's possible that this actually doesn't return. So I'm just going to return a bogus array here. And if I submit this code, you can see that it passes with flying colors. Thank you for watching this video.